So in this section, I'll be covering algebra, which is a fundamental really in your paper one, both trials and finals. And it's a very important section. Number one, to gain a lot of marks. And number two, I have not yet seen a student who's not good in algebra. So it is important that you understand it. And also you make sure that you get all the easy marks in algebra. And also it boosts your confidence. So I'll be going through a series of exercises I think will be super beneficial. And these examples are not limited to these. You have to do more of these so that you get acclimatized to how they ask questions and do them. So I'll be showing tips and tricks on how really to always get these correct in the exam. So the predominant question here will be what solving for x, meaning that isolating x in a sense. So the first question, you're given x squared minus 9x plus 20 is equal to 0. So we have to solve for x there. So this is a quadratic equation. And to solve this, we need to find the factors of 20. That which we add or subtract will give us negative 9. That which we multiply will give us positive 20. So factors are numbers that can go into 20 without leaving any remainder. And we'll write x and x, and those factors will be 5 and 4. So what sign should 5 and 4 be so that when you add them, we get negative 9, and so that when you multiply them, we get positive 20. It's negative and negative because negative 5 minus 4 is negative 9. Negative 5 times minus 4, you get positive 20. So you can really do trial and error to get all these factors. One trick that probably takes a bit of time that I would recommend is that you find all the numbers that go into 20 without leaving a remainder and write them down on the side. 1 goes into 20, we know that 2 goes into 20, 3 doesn't go into 20, 4 goes into 20, 5 goes into 20, and we know that 10 goes into 20, and 20 itself really goes into 20. So from this whole list, we'll look at the two numbers that really we can add or subtract that will give you 9. So the two numbers that stand out really, it's really 4 and 5, because 4 plus 5 is 9. Then you play around the signs to see what signs should 4 be and 5 be so that I get a negative 9. It needs to be negative and negative. What signs do they need to be so that when I multiply them, they give me a positive? So obviously it will be negative times negative, which will always give you a positive number. So always list them on the side and do trial and error. Failing which, use the quadratic equation. You always get your answers correct. So the solutions here will be x minus 5 is equal to 0, or x minus 4, or rather, you can really skip this step and just go to the solution and say x is equal to 5, or x is equal to 4. What we did there, we took these values on the other side of the equation and they changed the sign. So our solutions are x is equal to 5 and x is equal to 4. Even if you use the quadratic equation, you should get the same solutions. So let's move on to the next question, which is 2x squared minus 3x minus 7 is equal to 0. And we're told that to correct to 2 decimal places. This is always a hint that we have to use the famous quadratic equation. And the quadratic equation says x is equal to minus b plus minus the square root of b squared minus 4ac, everything divided by 2a. So what are the ABC? ABC is simply the coefficient of a is the coefficient of x squared. So we can simply list a, coefficient of x squared, and b, the coefficient of x. B is equal to negative 3, and c is a constant, which is negative 7. And note I'm taking the numbers and the sign in front of them. Then what do? We substitute all the values into that equation. In our equation, we have negative out of the b, and then we're going to substitute our b in brackets because it's negative, plus minus square root of negative 3 squared minus 4. Our a value is 2, and our c value is negative 7. Everything is divided by 2 times a. Our a is 2. And then we find our solution. You can punch that into the calculator. You should get 2 solutions. And also note that the solution said round your answer to 2 decimal places, meaning that your answer, when you write it down, it needs to have 2 numbers after the comma. So one solution is 2,77, and the other solution is negative 1.27. So that will be our two solutions for this quadratic equation. And another important hint, always list your values as you did A, B, and C. And this helps you in two ways. It saves you marks. And number two, in that sense that they use positive marking. So let's say, for example, you forgot that it's -3 and you wrote it's 3, which it can happen to the best of us, and you used 3 in the whole solution and you got different values there. They still give you all the marks and they subtract 1 mark for substitution. It's called positive marking. So always make sure you list your numbers so that examiners can see that, oh, these are the A, B, and C values that you used. And if you use them and substituted them correctly into your formula, this will give you all the marks, subtract 1. So if this question was out of 4 marks, it means that it will give you 3 marks, provided that you substituted that value and got the solutions. So always list your numbers. Always list your numbers A, B, C in a quadratic equation like this. So let's move on to the next question, which is number 3. And I'll try and delete this here so that we have more space to work with. So let's move our 3 to the top. So for number 3, we can see that we're given an equation that has a fraction. And usually students panic when they see a fraction. How do you solve this? We're given that 3x plus 1 over x is equals to 4, and we're told that x cannot be equal to 0, meaning that our solutions cannot be equal to 0. If you get a solution that's equal to 0, we don't accept that solution. We take the alternative if there is. So how do we get rid of this really denominator of x? Easiest way is to multiply throughout by x, meaning that on the left hand side we're going to multiply by x, and multiply by x. On the right hand side we also multiply by x. It's the golden rule of the equations. What you do on the left hand side, you also do on the right hand side. So what we'll get x times 3x, which is 3x squared. The x and the x will cancel, and you'll be left with 1 equals to 4x on the right hand side. Bring the 4x to the left hand side, then you'll have 3x squared minus 4x. The 4 changes. It was positive on the right hand side, it's negative on the left hand side, plus 1 is equals to 0. And you have quadratic equation again. So you have two options again. Either use a quadratic equation as we did here, or really use the factor method where you fill in the factors that go into 3 and 1. That will give you -4 when you add or subtract them, and that will give you +1. So we have 3x and x, and the factors will be 1 and 1. And since when you multiply them, it needs to be positive, it means both of them needs to be negative. And really, the more you practice these questions, the more you become more efficient. But if you're still struggling with these, I always recommend use the quadratic equation to always make sure you get your answers correctly, and also you save time. So therefore, solution will be x minus 1 is equals to 0, which will be 3x is equals to 1. And if we divide both sides by 3, we'll get x is equals to 1 over 3. So I'll just write the solution as x is equals to 1 over 3. The other solution will be x minus 1 is equals to 0, which will be x is equals to 1. So we would have calculated our two solutions, and none of these solutions is equals to 0. So we accept both solutions. So let's move on to the next set of questions under algebra. So this, we can label this number 4. And these now are surd equations. And surd equations are uber important, and learners most likely always make a mistake that I'll show you how to always avoid. So with surd equations, the idea is that you have a surd, and in that surd you have an x value that really you're trying to isolate, or a variable of x you're trying to isolate. So it's more or less detective work. So your hint is always the surd, and in that surd, if there's a variable, that's your key focal area. You'll try to remove everything over, beside, or under it to isolate that x value. And first things first, since now we have a square root, since our surd actually is isolated, meaning that that's the only variable in the left hand side or the right hand side of the equation, then we can proceed to try and solve it. So we can see it's not adding or subtracting anything. We can see that even if there was a number here, it means that it's attached to the surd. So if it's in this format, we can go ahead and try really to get rid of the square root. We get rid of the square root by squaring. We know that the square root and the squared cancels off. And remember the golden rule of equations, what we do on the left, we also do on the right. So what we'll have is that this squared value, 2, will cancel the square root. We'll be left with 2 minus x. And on the right hand side, really we just need to expand into two identical brackets. And then we have 2 minus x is equals to, what we do, we just FOIL x times x times minus 2 times x, minus 2 times minus 2. And what we will get when you do that, we'll get x squared minus 4x plus 4. Then really now we just need to group everything into one side of the equation. And we'll have x squared. If we take all these variables to the right hand side, we'll have x squared minus 4x. And the negative x will become positive x. And the positive 2 will become negative 2. And we keep the positive 4 equals to 0. Now we group our like terms, meaning that really I like highlighting them so that you're able to see them. Now we're grouping apples with apples, and we're grouping bananas with bananas. And also note I'm taking the sign in front of the numbers. So we'll have x squared minus 4x plus x will give us negative 3x. Negative 2 plus 2 will give us positive 2 equals to 0. Now we need to find the factors of 2 that which you add or subtract that will give you negative 3, or multiply that will give you 2. Remember in the previous questions I said you must list the factors. The factors of 2 are 1 and 2. So we need to find the signs of 1 and 2 that will give us negative 3. And you can see that when you multiply them, they need to be positive. So that's another hint. So we can make them negative and negative and see what we get. Negative 1 minus 2, you get minus 3. Negative 1 times minus 2, what do we get? Positive 2. So these are our factors. We'll simply open two brackets, equate to 0, x and write our factors, minus 1 and minus 2. So therefore our two possible solutions will be x is equals to 1 or x is equals to 2. And why do I say possible? Because we need to perform a very important step where we check our solution or we validate. And if you don't do this, you don't get all your full marks. So that's why I was saying this step is very, very, very important. So we're just going to validate our solutions just to check which solution is correct and which solution is not correct. So how do we do this? We're going to take the value of x is equals to 1. X is equals to 1, substitute it where there's x and see if the left hand side is the same as the right hand side. So we go back to our equation, which is, let me slightly make space on the side so we have to be able to work. So we go back to our original equation, which is 2 minus x is equals to x minus 2. So the first solution we're substituting will be 1. Substituting where there's x in the original equation. So it will be 2 minus 1 and it will be 1 minus 2. We have to see if this solution is valid, the left hand side should be equals to the right hand side. So 2 minus 1, we know that it's 1, and the square root of 1 is 1. And then we can see that 1 minus 2 is giving us negative 1. And we can keep that as negative 1. We can see that these are not equal. You can see that the left hand side is not equal to the right hand side. So therefore, we say x is not equals to 1. So now the assumption is to assume that x is equals to 2 will be the solution. But no, we also have to perform a check to make sure. Remember, we can't take chances. We need to take all the marks that we can take in the exam. So we just substitute 2. We see what we get. So the square root of 2 minus 2, we know that 2 minus 2 is 0. The square root of 0, we know that that will give us 0. 2 minus 2, we know that is equals to 0. So we can see that these are equal. The left-hand side is equal to the right-hand side. The left-hand side is equal to the right-hand side. So therefore, we can confidently say that x is equals to is the only solution to this equation. Then we would have answered the question. Please remember this and keep practicing these. So let's move on to the next question, which is a surd as well. So we're going to move on to the next question, which is a surd. We'll be applying the same skill we did in this previous question. So let's label this number 5. Question 5. So slightly note that this equation now, or this question, has a variable in front of our surd. So we have 2x plus 6 plus 2, and the plus 2 is outside the surd, is not under the surd, it's not under the square root. Note that. So now we have a delinquent number in front of the surd. What will you do with that? And we have plus 2. It's easy. We take the variable, what we don't want, onto the other side of the equation, meaning that we'll have 2 square root of x plus 6 is equals to x minus 2. The 2 was positive on the left hand side, skipped or jumped to the equals to sign, became negative. So always remember, any number that jumps or crosses over the equals to sign changes its sign. So now we've isolated the surd, right? So it's always advisable to keep this 2 so as to not complicate anything. Don't divide both sides by this 2. Keep the 2 there. What we're going to do is going to do the same thing we did on number 4 by squaring both sides. Why are we squaring both sides? We want to get rid of the square root. Part of our detective work. We're trying to eliminate everything so that we get to this x under the square root. So when you square this, when you square the left hand side, it's the same as saying you're squaring the 2 as well, and you're also squaring the surd x plus 6 squared. And obviously on the left hand side it remains really the same. So why am I showing you this? Because a lot of learners forget to square the 2 and they only cancel the square root. So what we'll get here is that we'll get 4, because 2 to the power of 2 is 4, and the square root and the squared here will cancel each other, and we'll have x plus 6, and we keep it in brackets, is equals to, we expand that to 2 identical brackets, x minus 2, x minus 2, and now we're simply boiling or distributing these brackets. What we have 4x, and 4 by 6, we know that it's 24. Now we do the same thing here, x and x and minus 2 and x, minus 2 and minus 2. We'll have x squared minus 4x plus 4. Then now we're grouping everything. So what we do, we take everything to the right hand side, and we'll have x squared minus 4x, this minus 4x, and then if you take this 4 to the other side, it will be minus 4x plus 4. If we take this 24, it will be negative 24, 4 equals to 0, and then we group our like terms, negative 4x, and 4 minus 24. What we'll have is x squared minus 8x minus 20 is equal to 0. Now we have a quadratic equation. How do we solve this quadratic equation? So I'll erase this part. If you still need it, you just pause the video and take a screenshot of it. So we have a quadratic equation. X squared minus 8x minus 20 is equal to 0. So we need to find the factors of 20, which is 1, 2, 4, 5, 10, and 20. Which of these two factors, when you add or subtract, will give you 8, and when you multiply, will give you negative 20. So I can see that 2 and 10. 10 minus 2 can give us negative 8. And we'll play around the signs, and 2 times 10 will give us negative 20. So what will the signs be? So we can say 2 and 10. But I know that negative 10 plus 2 will give us, add them, will give us negative 8. And I know that if you multiply positive 2 times negative 10, it will give us negative 20. So what do we do? Open two brackets, x equals to 0. We said it's negative 10 and positive 2. Therefore, our solution will be x is equals to 10. Possible solutions, x is equals to negative 2. Now, don't forget, we're dealing with a surd. The question was a surd. So we need to perform a check. How do we check? Substitute it into the original. So we're going to say 2 root of x value minus 6 plus 2 is equal to the x value. So the first x value you're going to test is 10. So we're going to substitute 10 with this x. So now it will be 10 plus 6, and then it should be equals to 10. So remember, we need to prove that the left-hand side needs to be equal to the right-hand side for these to be valid. So it will be 2 times 16 plus 2, and 2 times the root of 16 is 4, plus 2, 2 times 4 is 8, plus 2, which will give us 10. So we can see that the left-hand side is equal to the right-hand side, which is 10, which means then x is equal to 10 is a valid solution. So let's do the same thing for x is equal to negative 2. I'll perform a check for x is equal to negative 2 and see what we get, meaning that with this x, we're going to substitute negative 2. So minus 2 and minus 2. So 2 will be square root of negative 2 plus 6 will give us positive 4. Plus 2 will be 2 times the square root of 2 is 2. Square root of 4 is 2. 2 times 2 is 4. Plus 2 to give us 6. So we can see that it's not equals to negative 2. You can see that even the final answer there will not be equal to 2, because 6 cannot be equal to negative 2. So now we eliminate this solution. X cannot be equals to negative 2. The only solution to this problem is x is equals to 10. And that will be it for surds. So we can move on to the next one, the next question. And I found this question pretty interesting because it was a combination of surds and solving for x. So if we're given that the root of x minus 6 minus 2 is equals to 15, all divided by the root of x minus 6. So when you're given such a question, the key giveaway of what you need to do is that when you're given two identical expressions or variables, it's always really not have a headache here. Always label them as something else, meaning that we can say we can let the square root of x minus 6 be equals to our famous k, meaning that where there's square root of x minus 6, we're going to substitute k. That we have k minus 2 is equals to 15. And actually you can use any letter. This is just for simplicity. So now that we have k, you can see that we have a fraction. Now we have to eliminate the fraction. And how do we eliminate the fraction? We can just multiply everything by k. And what we do on the left, we do on the right. And then we'll have k squared minus 2k. And the k's on the right hand side will cancel. And we can bring the 15 to the left hand side. And now we have our famous quadratic. Open two brackets, find the factors of 15. And the factors of 15, 1, 3, 5, and 15. And which of these can give us negative 2? You can see that 3 and 5 are really a point of interest. You can say negative 5 plus 3 can give us negative 2. When you multiply positive 3 times negative 5 can get negative 15. So we can write really -5 and +3. And we can see that k is equals to 5 or k is equals to -3. But remember, we are solving for x, not for k, so we need to substitute back what k is. Meaning that where there's k, we're going to put the square root of x minus 6, which is equals to 5, or the square root of x minus 6 is equals to -3. Then now can you see that we have a surd equation? We have two surd equations. And what do? We apply the same procedure. Square both sides. Then we'll have x minus 6 is equals to really 25. Then we're solving for x, therefore we take the 6 to the other side, it will be 25 plus 6. Therefore our x value will be equals to 25 plus 6, and then it will give us 31. Means one of our solutions is what is 31. We do the same thing on the left hand side. Square the left and the right, and we'll have x minus 6 is equals to 9. Then we have x is equals to 9 plus 6, x is equals to 15. And really those will be our two solutions. X is equals to 31 and x is equals to 15. So you might be asking yourself, do we perform a check for these, or we don't perform a check? We do perform a check. So we need to go back into our equation and substitute x is equals to 31 and x is equals to 15 and see what solution you get. And you can quickly really do it on your calculator to see what value you get on the left hand side and see if really it's consistent with the right hand side. And you can quickly write it down here and see what value we get. So if we substitute 31 there, you can quickly substitute it either in your calculator. On the left hand side you get 3. And then if you simply substitute on the right hand side 31, you'll see that you also get 3. So from a quick calculator work, I can see that 31 is a solution. And if you quickly substitute 15 where there's x on the right hand side, you'll get 5, and on the left hand side you will get 1. So you can confirm that really x is equals to 15 is not the solution, and the only valid solution is x is equals to 31. So practice these, and if you want more of these exercises, you can really get them on my study guide, Crack the Maths Code. There's a litany of exercises that are really scaffolded very well and really are exam type questions.